Hi, myself and Arun Kumar from Excellence College of Technology in the Department of EC. In this video, I am going to share about routing algorithms in data link layers. So the routing algorithms are based on forwarding process. Forwarding means to place the packet in the routes to its destination. Forwarding requires a host or router to have a routing table. When a host has a packet to send or when a router has received a packet to be forwarded, it looks at this table to find the route to a final destination. So in this video, we are going to discuss about forwarding techniques, forwarding process, and routing table. So route method versus next hop method. So there are some two techniques which is to be followed for tabulation methods. First one is routing table based on the route. Routing table based on the next hop. Hop is it is a network which is used to be connected to the neighboring nodes. Next one is router is used to forward the data to all the neighboring nodes. Initially, the destination and route node is same, but the thing is in next hop is it just sending the data only to the next neighboring node only. But in this case, in routing table, we are going to send the data all the network which is to be connected in the host. But in host next hop method, we are sending the data only through the next neighboring node. So host B is receive only the neighboring node as R1. Like that, all the information has been forwarding to the next level. So default method is the router. The router just sending the data to the next node, and then if you want to add some more routers, mean it is also transfer the same information to the next node also. So routing protocols are based on distance vector, linked state, and path vector. So distance vector method is a very useful method to find the shortest path of the distance between the any other nodes. Initially, the distance vector routing protocol has been calculated based on the number of nodes which is to be very nearer to the next node, so that the corresponding cost factor also we need to write. In this method, we are going to find the distance between A to F, A to E. So we are using only 5 nodes. In this, we are going to find the shortest distance between A to E. The table has been formed based on the number of nodes which is connected with each other. Initially, the starting from A node is A's table. So A node is connected B as and their corresponding A to A is 0, and next one is A to B and the cost factor is 5. Next one is A to C. A to C is and the cost factor is 2. A to D is very near, very nearest to the next node. Then the cost factor is 3. And A to E is it is far away from the starting node A. So that we just eliminate the E node by connecting infinity value. So only thing is the next node it does not connected to the neighboring node, so that we can find the next node. So the next node is it is very shortest to the corresponding destination node, so that I can choose this C will be the next node of E. While choosing B is the weight of the corresponding B A to B is 5, so we need to eliminate the cost factor also. Based on the cost factor only we need to decide, because while forwarding the data or information to the receiver side, we need to find out the cost factor. The cost factor is very minimum to the next node, so that I am just taking this C node as a immediate neighbor to the E node. So I am just taking C node as a next node. So like that, all the values has been formed or framed in this table. Finally, we are received the tables to the cost factor based on the cost factor. While the infinity value is coming from the faraway distance has been carried out as a infinity value. So A to A 0, A to B 5, and C equal to 2, and 3 D for D3. For E is equal to far away from the distance between all the nodes. So I am just making my connection as infinity value. So because we are going to eliminate the number of nodes which is to be far away from the starting node, so that we can calculate the shortest path of the corresponding source node to destination node. Finally, we are receiving after eliminating all the infinity values and the neighboring faraway distance, we can comparing the previous value along with the cost factor so that we can get the final answer as A to E is equal to finally we can get the C equal to C6 value. Next one is link state routing. The same example we are followed this link state algorithm also. The only thing is we don't write any cost factor for this value because cost factor also one of the parameter which is define the routing value. But in the thing is here we are not putting any values here. But calculate the values based on the previous neighboring values. So the thing is, while writing the value of A to B means we need to calculate the previous link value has to be checked, and then we can write the tabulation. For example, if you are sending the data from A to D means initially we can calculate the A value and B value, C value, D value, E value. We need to calculate the distance also corresponding distance also for the tabulation. And then if you want to transmit the information from C to E means we need to calculate the previous lowest distance of the corresponding tabulation. Then we can add the previous tabulation also, so that it means that whenever we can forwarding the data to the destination N, we need to add the previous value of the previous lowest value has been added to the next one. Next one is Dijkstra's rules. This is also a method to calculate the link state model. In this method, we need to forwarding the informations. First one is A to B equal to 2, then they are mentioned here as 2, and A to C the cost factor is 4, and next one is A to D. So A to D is far away from the distance, so that I'm just making my connection as a infinity one. And also A to E also it is far away from the distance E, and A to F also it is far away from the distance, so that we can make it as infinitive. So we are framing the table based on the number of cost factors. So next one is we are going to limit the cost factor based on the number of nodes. In this minimum cost factor need to check, and then based on the minimum value we need to send the data to the next level. For example, B is getting only the less cost, so that I am just making this one be a next node, and then it just forwarding the information to all the nodes. So like that, all the values has been sent and identified based on the cost factor. The cost factor must be a minimum one. Then only it can able to transmit the next node of the corresponding source. Assessment. The distance vector difference between distance vector routing and link state routing. So some of the parameters they are mentioned here for making the connection as a long-term connections. The concept is routing loops are it is high, but is in this case no routing loop because it's a link. Previous link has to be checked. The techniques remaining and all same only. The update method is periodic method, but in this case is trigger the previous one. Algorithm is Bellman-Ford algorithm, but here is Dijkstra's algorithm. Next one is scalability, suitable for a smaller network. It is larger and dynamic networks because it is based on previous state, so that we can use for large number of applications. So example is WIP. Here is open source spot first algorithms. Thank you.